Welcome back, everybody. We're going to keep going in Chapter 11. We're doing Lesson 3. It's solving radical equations. So in this lesson, you'll be able to solve equations containing radicals and identify extraneous solutions. I'll talk about that later. Language objectives will be you'll be able to define what a radical equation is and what are extraneous solutions. Okay. When solving a radical equation, what you really want to do is get this radical by itself. Okay, so remember, a radical equation is an equation that has a variable in a radicand. So the radicand has an x here, so I need to get this by itself. So the first thing I'm going to do is get rid of this minus 7 by adding it. So as you can see, I added 7 to both sides, and now I have the square root of 4x equals 8. Next, I'm going to square both sides. So remember, the opposite of a square root is a square. They cancel each other. So if I put an exponent 2 here, a square here, I have to do it here. But when I do this, this cancels this, and this is out of jail. It's out of jail free pass. So write the radicand all by itself, okay? So the 4x just comes right out, just the way it is. And then this becomes 64. If that's hard to understand, you can square 4 and get 16 and square x and get x squared and then square root them, and you'll get the square root of 16 is 4 and the square root of x squared is x. If you need to do that, do that. Otherwise, this 2 cancels the square root. Okay, now let's solve for x. I divided both sides by 4 and I end up with x equals 16. We have 3 practice problems to try this on. So right away identify where the radical is and get rid of everything else, get the radical all by itself. So let's get rid of this plus 8. Now I have the square root of 3x equals negative 6. So next I'm going to square both sides. Remember that a square cancels a square root, so my 3x is free, and I have 3x equals 36. Next, all I need to do is divide both sides by 3, and 36 divided by 3 is 12, so I end up with x equals 12. Notice it says check all your answers, and we have to talk about that. Because we're dealing with square roots, remember square roots can be positive or negative, we need to take this 12 and plug it in, and I'm going to do that and watch what happens. So I took the 12 and I put it right here. So 3 multiplied to 12 is for sure 36, and the square root of 36 is 6, but 6 plus 8 does not equal 2. So this is an extraneous answer, meaning this answer won't work. This is a no solution. We can't solve this one. And one way if we look back, it says the square root of this is negative. And now, remember, with square roots, if they want a negative answer, they need to put a little negative out here to imply that they're looking for the negative root. All right, on this example, our square root is all by itself, so I can already go straight to the step where I'm going to square both sides. Remember, a square cancels a square root. So this entire binomial, x minus 5, comes out, and it equals 16, which is 4 squared. Now I can quickly add 5 to both sides, and I get x equals 21. We can plug that in. 21 minus 5 is 16. 21 minus 5 is 16. And the square root of 16 equals 4, and that's what they show up above. On this question, I have 2 square roots on both sides, but they're both isolated, and that helps. So I'm going to square this, and basically they both disappear. So I end up with 3x minus 4 equals 2x plus 3. So let's quickly solve this. And I end up with x equals 7. If I plug the 7 in here, I checked it, I do get the square root of 17 on this side, and if I plug it in here, I do get the square root of 17 on this side. Okay, I would like to talk about what is an extraneous solution. An extraneous solution is going to be a solution that does not satisfy the original equation. In other words, if you plug the number back in, it won't work. It won't give a true statement. So let's just pretend our equation is x equals 3. Okay, x equals 3. Fair enough. What if I square both sides? So I get x squared and then I get 3 squared. So my new equation is x squared equals 9. All right, so I need to find the solutions for this new equation. Well, how do I get rid of a square? I square root. And if I square root both sides, I get x equals 3, or remember, the square root of 9 could also be negative 3. Then it says, do both of my solutions satisfy the original? Well, this does. The original is x equals 3. That sure does. But x equals negative 3 does not. So this is an extraneous solution, meaning, yes, it's a solution, but it won't work, so we can't use it. So we throw it out. So the only answer we're going to write down is this one. All right. Let's practice and see if we find an extraneous solution in this question. We have a square root. It's all by itself. So how do we get rid of a square root? We need to square both sides. So I'm going to square this and I'm going to square this. Now, when I square x, I get x squared. Next, this square cancels this square root. So what's left is x plus 12. Here's how you solve an equation like this. You get all of the variables and constants on the left side. You move them all to the left side. So I need to move x by minusing it. So I'm going to end up with x squared, and then I'm going to minus x to move it. Okay. How do I move the 12? I minus 12 to move it. What would be left on this side after everything moves? A 0 would be left. Well, now I'm going to factor. I'm going to say what times what is negative 12, but adds to negative 1. Well, negative 4 multiplied to 3 is negative 12, and if you add them, negative 4 plus 3 is negative 1. So I'm going to put x minus 4 and then x plus 3. Remember, when we factor, we take an addition problem, or a sum, and make it a product. Well, now, if I have something multiplied to something equals 0, what do I know about that? Let's look up here. If I have, like, n multiplied to 8 equals 0, I know that n must be 0. Or, if I have 8 multiplied to x, and that equals 0, then x must be 0. If I had n multiplied to x equals 0, what would I know? I would know, well, one of them has to be 0. That's what we're going to do right here. We're going to take this parentheses and pretend that it equals 0, because it could, because one of these parentheses equals 0. Then we're going to take this parentheses. All right, so I set both parentheses to 0. I think I have a little mistake here. This is minus 4. Okay, and that's plus 3. All right, so let's solve this parentheses on the left. How do I get rid of a minus 4? I add 4 to both sides, and I get x equals 4. We will check that in a second. I'm going to minus 3 from both sides. I get x equals negative 3. All right, so if I plug this in here, it will become 0, and then that could work. And if I plug this in here, this will become 0, and that could work. But we have to check for an extraneous solution, so we need to take each number and plug it into the original to see if it is true or false. The original equation is x equals the square root of x plus 12. So I took 4 and put it where the x is. 4 plus 12 is 16, and the positive square root of 16 is 4. This works. Now I need to check the negative 3. Same thing, negative 3 equals the square root of negative 3 plus 12. Well, negative 3 plus 12 is 9. The square root of 9, Now, when we have a square root, it implies the positive root, because otherwise they would have a negative outside. So the square root of 9 is 3, not negative 3, because they didn't put a negative on the outside. So we would not use this answer. This answer we will not use. So the answer we'll use is x equals 4. All right, 3 more practice problems. How do we get rid of a square root? What we do is we square both sides, and when we do that, the square root disappears, so we end up with 7x minus 3 equals 4 squared, which is 16. Let's solve it railroad track style. That's exactly what I did. I added 3 to both sides, and then I divided by 7. I end up with the fraction 19 over 7. But if I plug that in, it's going to work, because 7 multiplied to 19 over 7 cancels, and I end up with 19 minus 3 is 16, and the square root of 16 is 4. So my answer works. Here I want to square both sides, and when I do that, remember, the square roots will disappear, and I end up with the binomials. Alright, so now all I have to do is solve this equation. I showed my work, added 2 to both sides, then I minused my x over here, so I have 2x equals 4, so x equals 2. I'm going to double check it. 2 plus 2 is 4, so this is square root of 4 on this side. Then I'm going to do 2 multiplied to 3 is 6. 6 minus 2, sure enough, is 4. So, sorry I wrote, okay, so the square root of 4 equals the square root of 4. So 2 equals 2, it works. One more example. Our square roots are isolated, so let's square to get rid of them. So when I square, this cancels, and I'm left with 2x plus 7 equals 5x minus 8. So now let's solve it. Okay, so I minus 2x from both sides, and then I added 8 to move it, and 3x equals 15, so I know that x equals 5. Quick check. 5 times 5 is 25. 25 minus 8 is square root of 17 is 17. Let's double check here. 5 times 2 is 10, plus 7 is 17, so I have square root 17 equals square root 17. It works. Here are the practice problems. Please check for any extraneous solutions or any no solutions. There's some in here, so check for them. And bring any questions you have to class next time we meet. Take care.